we have Amnat Khamsirwatchara, Biophics Director, who will describe to us the workflow of the randomization process for both blinded and unblinded processes. In addition, he will demonstrate the workflow and checks related to randomization. So thank you, Amnat.
Hello, everyone. My name is Amnat Khamsirwatchara. I'm a director of the Center of Excellence for Biomedical and Public Health Informatics. I'm very pleased to be a speaker in this virtual DFUG 2021 this year. My topic this session will be on the electronic randomization using DFdiscover. Here's the topics that I'm gonna cover, starting from definition of the E-randomization control process, and then the study scenario that we're gonna use, and then show you the E-randomization system as follow. And then finally, with the conclusion of the E-randomization using DFdiscover. Let's start from the definition of the E-randomization control process. It will be starting from the manual list that's generated from the unblind statistician, and the number of the list will depend on the study scenario, and then follow with the subject will be enrolled in the study and is deemed eligible for randomization. Once they are ready, the clinical site will be given the randomization value, which normally handled by blind user clinical research coordination, and then those values will be associated with that subject always. And then randomization value has been given to the participant. He or she will be proceeding to the unblind user, which normally will be pharmacist. He or she is the only one who knows the code, which will be tied to the randomization value. And then final, the unblind user will give the treatment to the patients or the subject based on those randomization value. That's the end of that's the definition of the control process. So let's look at the study scenario. In this particular demonstration, we will we will recruit 418 participants from only one clinical site, and then he or she will be, the participant will be given treatment arm as shown. So if you look at this scenario, it's a very simple scenario. You need only one randomization list to be put on the system. And then to follow on that, you need to be able to split those into group like the scenario show you here. And the day 1, day 3, day 5, and day 7 onward should be follow the sequence of the. How do we do that? You need to look at the randomization treatment list here. So this is the list that unblind statistician created. So he or she will look at the scenario and then generate. If you look at the file, you will see that this is the sequence. So starting from sequence 1 to sequence 418. And this is the randomization ID, which will be a randomized value, which has meaningless, but it stick to the arm treatment here. So this number should match with arm treatment here. And the size and the group of it will be classified by this one, day 1, day 3, day 5, and each proportion have to match with the study scenario here. So on day 7 onward, it will be with block of 20. So the randomization system should control what? It should control the order or the sequence, this order or sequence, from sequence 1 to match randomization ID, and this randomization ID should match with treatment arm here. For the first match will be run by blind user, and the second match will be run by unblind user. So here's the concept of how to control this E-randomization. If you can assign this correctly, everything will be randomized by default, and all the size and the group will be matched based on the file that create from originally from unblind statistician. Let's look at further of how the system keep track of that. After you get the list from statistician, you should prepare the first list for the lookup table, which will be implemented in DFdiscover. So this is the lookup table, which contain only 2 columns. The first column will be a sequence column, and the second will be a randomization value. So the blind user will only know only this, and he or she will not know the third one, the third column. And the third column will belong to another file, which is a CSV format here. As you can see that there are 3 columns here. There are sequence column, randomization value, and the arm treatment. So this list will be handled by unblind user or pharmacist only. Nobody should be access to this particular file because this is the confidential file. It should be open at the end of the study to be unblind. So that's the key element of how to do the randomization control in the system. Once you prepare those 2 files successfully, you are now ready to create an eCRF here. So the first CRF will be based on blind user. So the blind user will use this random page CRF to assign the randomization value. And the second page will be for the arm page. It will be for unblind user to review the arm, treatment arm, which match with randomization value. And the third page will be admin sequencer page. So this is how the system control the sequence. So if randomization value has been assigned, this admin sequencer page will keep track of that sequence. If you convert that file into a flow, it should look up like this. So the statistician prepare the unblind randomization list. As I told you, in this particular scenario, it needs only 1 file because our scenario is not that complicated. So we need only 1 file, but I put here as XX files because sometimes it depends on the study. If you have multiple sites, if you have different strata of criteria to be included in this study, suppose you want to split age group or risk group into high group, low risk group, that will depend, the number of randomization lists will be more than 1 file. Anyway, after you got that file, you will split. Now it starts with the DFdiscover system. By DFadmin will split those files into 2 sets, like I showed you in the previous slide. The first will be for lookup table, which will prepare the lookup table here. And another set will be prepared for the CSV unblind, which will be put in some place in DFdiscover server, a secure one, which only DFadmin know that which directory that is, and will set permission. Only DFadmin can access this particular file. No one ever be able to write or read this file. After that, on the randomization lookup table, it will you will create with the 2 pages of CRF, which is random CRF and admin sequencer CRF. And for CSV, you will create a treatment arm CRF. So the setup flow will be like this one. No matter how complicated you are, you can follow this flow. It will be running as expectation. Now we come up to the E-randomization system, which will be implemented in DFdiscover, starting from blind user. So here is the scenario that you have probably multiple CRCs, like CRC1, CRC2, which will access the DFdiscover. He or she or both user will validate the random page. Let's say at clinical site 1. If all criteria are passed, CRC will enter the subject ID and they will be ready to assign the randomized value. After successfully assigned, the page will be stamped with username of both of either one of this, and then with the date timestamp from the local machine that they use in the area. Once the randomized value has been assigned, the admin sequencer page that I mentioned will also get update the sequence. If the patient number 1 has been assigned already, the sequence will running as sequence 1, and the second has been assigned, the admin sequencer will update in sequel. Let's see the real system. Here's the real system of the random page before randomization. So this is, once you log in, you will see the page 401 here. The page 401 will be for blind user. For blind user, only one plate that can be shown by this screen. So they just enter the subject ID and input the other criteria as stated in this study scenario. Once they assign all the criteria correctly, they will be ready to give the randomization number. If they successfully get the randomization number, the admin sequencer page will be updated as this. So this is the automatic page that by user don't have to do anything, but it will update automatically. Here's the decision flow when they click on the random number result. If they decide at the beginning that is going to start the randomization process, there will be a dialog box for them to select whether to go on or not. If they select no, they can get out of the record by move away from the page and put this guard chain here. And if they decide to move forward, they can select yes and then save the plate as final. At this particular point, they still have a choice to whether get back by click no, or if they're sure that they're gonna process the randomization, they can click yes. Once they click yes, the system will assign the randomization value number. As you can see here, that number 3000744 will be assigned. And they can print out this form and give to the unblind user later to get the treatment arm in the next step. So I can show you in the real picture like this. If the subject ID getting in here, the admin sequencer will update the sequence like this. Suppose if another CRC get in at another time, this is the second subject ID that enter, and the admin sequencer will get updated sequentially as shown here. And this screen will be a permission for blind user. So as you can see that in plate 401, they have permission to create and modify, and 403 is the admin sequencer page that they have only created page, because when assigned with 401, when the blind user update the page, they have the right to enter the date timestamp. That's why they need to be able to have a right to update and update the sequence of the admin sequencer page too. And here are the edit checks that related to the blind user page, random page. So the first one is for specification for lookup table. as you know that there are 418 participants, so the max number should be 3-digit, like 408. So this will define the value of the admin sequencer page, that it has 3-digit. And then the character will be a length of 3. And then on the second spec, it will define the criteria based on study scenario, that if they are aged between 18 and 59 or all of the criteria has been passed, it will be ready to randomize. For the page 3, for the step 3, 4, 5, this is the step that how admin sequencer run. So thanks for Tadas, who is the programmer from the DFnet research, who provide this kind of edit check, which can be run very powerful and stable. So we can implement this very easily, and we try on the demonstration page. It worked perfectly well. So thank you for the support from the DFnet research. After this page has been updated, you can use DF SQL load to extract information to another system and use Power BI or business in any business intelligence which can capture those kind of data and produce this kind of monitoring report. As you can see that there are 418 and they can enroll up to 55%, something like that. So this is the information that extract from the random page, which will be very useful for the site to tracking the progress of the study very in a very near real-time format. That's it for the blind user. Now we move on to the next step for unblind user. Again, the unblind user will belong to the pharmacist who know the unblind treatment that match with the randomization value. So starting from the pharmacist, open the SIRM treatment, and it will read the randomization value from the CSV file that we prepare from the beginning step, because the system will look for the randomization value which match with treatment arm. And the treatment arm will be reviewed for pharmacist, because he or she will get those vaccine or treatment from the inventory and give it to the participant. Once the treatment has been given successfully, the system will stamp with success status. And behind the scene of this one, the random CRF, I mean the CSV file under the DFdiscover that hide in the directory will get update. What will we get update? There will be 3 fields that will get update. First is the subject ID. Second is the pharmacist username. And third is the date and timestamp from local area. So this is the information that will update behind the scene in a CSV file. And once it gets updated, it will synchronize it to another CSV file which will be writing exactly the same information. So this kind of CSV is like a mirror to each other. And then the mirror file will get updated and used for report or anything that, suppose you have a pharma controller who control the inventory of the drug or treatment, you can use this kind of information to update the information real time. So this is the sample page of the random page here. So when unblind user coming in, he or she will be able to see both plate in 401 and 402. The first plate will be random page, which the plate, this will be only view only, because they won't have a right to change, but they can view it to recheck the information whether the participant in front of them has this kind of information correctly. After that, they are ready to give a treatment arm. So the randomization will be copied to this page again, just for the purpose of lookup in CSV file. So this is the flow when they about to get the treatment arm. Once they click on this random number result, the arm will be pop up. The way that we decided like this because we don't want to write the arm ID in the plate because it's confidential. When you write down into the treatment arm page, it might be reviewed at somewhere. So we want to keep it like a pop-up like this. But in the real world, if the participants still don't want to get vaccine, they can get out. So the pharmacist can get back off from this point by click no here or leave the page without anything. It won't be writing anything in the database. But if the participant move on with the treatment, they will click yes and save it as a final. And then it will confirm again whether you want to proceed or not. If you still want to back off, you can still get out from this point by clicking no. But if you not, you click yes. Once you click yes, because this has been reviewed already, so once you click yes here, it will give you the success status because it has been applied to the patients already. Username, date, timestamp will be stamped in the plate. At the same time, the CSV backend will get updated here. As you can see, there are 3 columns will get updated. First is the subject ID, and second will be username, and the third one will be date and time stamp. So this will be get updated. At the same time, again, it will push synchronization of the CSV file into another area of the secure for reporting purpose to the pharma controller. This is good for the big trial who have multiple sites that have to report the inventory of the drug or treatment. You will get this report in real time. And again, this is the permission page that will be used for unblind user. So you can see that this is 402 plate, and it will have the right for unblind user to create and modify. And on this 401, this is the for blind user that cannot have anything, they can just view only. And this is the CSV file behind the scene that I mentioned. As you can see that this is sequential 1, the randomization value 1, and the arm treatment has been given successfully. So the site subject ID will get right on this one, and username with the date and timestamp from local area will get updated. At the same time, this file will be pushed to another file, which is the same file, and then but located in different locations. This is the way that you can synchronize this file and then do the report out of it later. And this is an edit check that will update on that. So it will have some method to write on the CSV file that as shown as follow. So here is the method in the CSV file that the edit check a while ago will be called them for 3 methods. So the first one is show method. Show will show the corresponding arm ID that it will look for randomization value and match with the arm treatment. And timestamp here, it will stamp the timestamp once it has been assigned success status. For the right it's just the command that it will write what kind of information that will write on the CSV file. So these three methods will be written in the CSV file, and then the edit check will call out this kind of method to be execution later. So this is before ending. This is something that also Tadas, who is the programmer at DFnet research, written out. There was some scenario that you cannot access the system. Sometimes there were power outage. Suppose you run the randomization online successfully for 3 cases already, but then another 5 cases on another day, there are power outage at the site for, let's say, half day, and those 5 cases cannot access electronically, but they are sit in front of you. You have to do the process. So some manual procedure have to be in place. So the blind user and unblind user have to use those manual convention to update, to do the operation at that particular time. And then after that, when the power restore, actually they cannot start the process right away. They need to clear out those manual that they have been doing before they get back to the same process. By clicking this manual here, and then once you click manual here, it will be trigger this process, because the system know that 3 sequence has been assigned already and looking for the 4th value. So if you don't put this 4th value as 636599, the system will not allow you to go through. This is another edit check that we put if the manual process has been applied. And then you need to finish those 5 records of the manual convention first before moving onto the electronic, before you get back to the electronic original way. And also for the unblind user, you have to do the same thing. But for the date timestamp, you need to put by your own, because the date timestamp will be at the time that you do manual convention. So that's it for the electronic randomization control process. For the conclusion for E-RANDOMIZED using DFdiscover, I think there are a lot of advantage here. Starting from increased startup efficiency and boost productivity, because we can do this very, very quick, because we need only 2 pages to initialize. So you can do this right away and save a lot of time. And from the PowerPoint that I show you, I think it can be used as the interactive response technology IRT to optimize the randomization process. And then it can reduce the trial risk by replacing either manual randomization process or IVRS in interactive voice response system. And you can deliver balanced and unbiased randomization when SQL. If you can use the system assign the sequence of the list correctly, everything will be controlled perfectly. And DFdiscover can be utilized to cover the entire process of the control randomization, even the replacement. Actually, I haven't mentioned the replacement process, but we can write an edit check to cover that kind of process too. And we think that it is easy to use and have the same environment CDMS and save a lot of costs. And it can handle large amount of participants and improve drug supply chain management. As I mentioned you on the unblind side, if you provide the report on the CSV report, you can know that how many drug has been distributed and provided to the site sequential accordingly. And it is flexible and customizable, as I show you that it depends on the number of the randomization list that you can generate per study criteria. So you can handle no matter the criteria has been complex, so you can generate based on the list. Even mid-try adaptation can be applied if you want to change something in the middle. You can do that, not that difficult. And again, dashboard monitoring is very useful for the tracking real-time randomization progress. And last one is the traceable and auditable, which is the features of the DFdiscover that has in place already with the audit trail. So that's it for the presentation. Thank you for listening. If you have any questions, you can put it after this session. So hopefully it will be useful for the DFUG user group in this year. Thank you and goodbye.
Thank you so much, Amnat. Besides time zone differences, we have you here today, so we really appreciate that. We are 5-6 minutes behind the schedule, but I think we can take at least one question, and maybe the rest can be answered on the chat during the break or offline. I'm just seeing one question that I think it was answered already by Taras. So many cheers to you, Taras. That's great. And we will take this question and we will go for the break. So what if, this is a question for you, Amnat. What if the file is accessed at the same time by DFtrigger? It's understood the record will be different, and an example will be a different site user.
You mean the different record or the same record? Because the DFdiscover will lock the record already. I mean,
I understand the record will be locked. My question is the file in the background on the server is accessed by two different users at two different sites running one record, running two different records. So who would have the priority on the files? And
you mean the CSV file backend, right? When suppose they update at the same time. Actually, we haven't coped with that situation, but
because that's something we had when we wrote our randomization sequence, and I had to modify things to take care of all that. But the idea is that is a real risk as this blows up into more and more sites and more, not to mention the size of your file and the time it takes to parse that file becomes extremely exorbitant if spread over different site sizes. So anyway, that's what I've already looked at, and that's something you're going to find as a problem. Anyway, thanks. Bye-bye.
Okay.
Thank you. Thank you, Ben.